All right, now that we've got it in this form, we've learned a few things about the direction, etc. So the question is this, well, what is the total electric field? If I were to integrate this and add them up, isn't that total electric field, isn't going to be the sum of all the dE cosine thetas? All of the parallel ones as I walk my way around the ring. So the question is, what can I do with this dE cosine theta? All right, now everybody knows that the cosine of some angle, let's say right here, this theta, is going to be the cosine of theta, is going to end up being the adjacent divided by the hypotenuse, which is z divided by r. Okay? And if we look at z divided by r, we know that r is going to be equal to, well, let's go back to our old friend over here. R is going to be equal to the square root of z squared plus big R squared. Well, it's just simple math here. We just take the square root of both sides, boopity boom. So now I can look, and I know that the cosine of theta in this particular problem is going to be equal to z divided by r, which is z squared plus r squared, like so. And instead of writing the square root for there, can I write instead of the square root sign, can we put, this would be to the half, like so. Okay, looking good like that. All right, now, let's take a look here. We've got ourselves our E total here, which is equal to the sum of all of the E dE cosine thetas. All right, like so. That's what I'm looking for. All right, now let's see if we can actually take a look and combine some of these ideas. Well, what is dE? dE is 1 over 4 pi EO times lambda ds divided by z squared plus r squared. Kind of nice like that. Now, this is just dE. I don't want dE, I want E parallel, dE parallel to this. So I've got to multiply it by the cosine of theta. Well, what the heck's cosine? Well, it's z divided by z squared plus r squared to the 1/2. All right, now if we clean this up a little bit like this, we're going to end up with 1 over 4 pi EO lambda ds, and there's a z up in the top, looks like that. Now, what is z squared plus r squared times z squared plus r squared to the 1/2? So on the bottom, we're going to end up with z squared plus big R squared. See, 1 plus 1/2. Oh, that's like 3 halves, isn't it? So we end up with 3 halves in the bottom, like so. Okay, and voila. Now, we're going to have to integrate this. So we take this, and we're going to sum up all of these in this simple 15-step problem as we have here.